Welcome everyone to this fifth session of the AI Academy. We've already had 4 fabulous sessions here before on the potential of AI, on its place in the digital ecosystem, the ethics and legal considerations. The last one was on the foundation or the first steps of building AI. And today we're going to talk about the AI proof of concept. So this section is AI proof of concept, learn to achieve success with proof of concepts for image recognition, natural language processing and predictive maintenance. We have 3 presenters today. So Chris Feldman of Intel, Robin Meehan of Inner Wisdom, and Lee Baker from Selden. So how are we going to run today? We have first Chris' presentation up, followed by a short Q&A. Then we have Robin. After that, we have a little mini break, but you can you're happy to stay along, and we have a bit of a longer Q&A, and then we have Lee Baker's presentation from Selden. And then we have some concluding remarks. And often we keep the line spoken after that as well. I'm going to hand over to our first speaker, Chris. Chris, if you can start sharing your screen.
So thanks everybody for joining again. Good to see some familiar faces. And as the setup's been talked about already, we're going to talk a bit about proof of concepts today. And first off, really interesting to see the survey, and the way the question was asked, and often how these questions are interpreted is interesting. And we asked a question about whether proof of concepts were successful or whether they failed. And I guess one of the really interesting things we find as we're talking to people about this is, what does success actually look like for a POC? Are you defining a POC as successful if you generate something that works? Is it successful if you learn something? So this interesting, maybe we'll get to some of the questions later on to see, what do people actually define as success for their proof of concepts? I think it's tempting to say success is when you've designed something that you can then take to a full production system, and it's tempting to look at POCs only in that guise. But in fact, there's a lot of things that can be learned for a POC, and success can mean many things. So hopefully we'll get to some of that. So what I'm going to talk about today, really when we were talking about the sessions, was based around this white paper that we have around 5 steps to an AI proof of concept. And the point here is not to, kind of hard limit everyone to 5. Obviously, there are different models here, but really to educate people and talk about what are some of the common things that we see customers doing with POCs. And typically, it comes out to around about 5 steps. And we wanted to share those with you to give you an idea of how people are doing POCs today. What are they getting from them? What are their outcomes? And then specifically want to drill into one particular piece of running a POC, which is when you're dealing with AI, there are some potentially quite heavy lifting elements, even of just a POC. And what is there available that can help you accelerate some of that so that you can actually get to POC outcomes quicker rather than getting bogged down in some of the technology. And we'll go through some of that. So really just want to focus on a few things, and the 2 things are outcomes and goals and phases of POCs. And again, this is information that we've kind of collated after working with lots of companies on different AI POCs, and different companies have tackled this from different ways. But when you kind of boil it all down and look for some of the common themes, it really comes down to stuff like this. And like I said, it is really tempting to think of a POC as being a technical evaluation of something to prove that you can actually do a task or deliver a capability. And certainly there's truth to that. But really, when you take a step back and look at something that's emerging as a technology like AI, something that's new to people like AI is in a lot of cases, it really does go beyond just proving the technical capability of a solution. And when we look at what people have told us they learn from POCs and what they actually look to get from a POC, beyond those obvious things, there's some new common themes around skills and experience in particular. And I think we're seeing a lot of companies really acknowledging that there's a lot of things they don't know about AI. And so they might have an idea about how AI could be applied to their business, but one of the key barriers they have is potentially skills. They haven't got experience in that domain. They don't have people who have the skills to go and deploy AI. And so partly the POCs can be about understanding the skills, and do we have the skills necessary to do some of this work. And we've seen some POCs put together purely around identifying skill sets within the companies, really nothing to do with the solution. The solution was almost a means to an end. And in this case, the end was understanding the skills that the company has. Clearly, there are a lot of companies who are defining their POC in terms of testing hardware and testing software and looking at different possible ways to deliver a capability. And so that's certainly true. And within that comes, identifying bottlenecks that might exist. And that might be, technical bottlenecks, computing bottlenecks or storage, things related to infrastructure, but it can also be related to the business as a whole. And so, for example, are there process bottlenecks? And quick answer to the question, yes, I'll be sharing slides after the call, sorry. So you don't have to scribble notes. So think about this as broader than just a technology proof of concept. It can also be about how a new capability is going to integrate into the business and into the processes. And if you think about a specific example, session 3 around the AI Academy was all about ethics and legality. And so whilst there's clearly going to be impacts on IT infrastructure from the adoption of this new technology, as we've discussed, there's clearly huge implications potentially to decision making, to ethics, to accountability, and POCs are a good place to start exploring that. You may not come to an answer within a POC, but by running through it in a kind of controlled and limited fashion, it's a good way to start highlighting where those impacts might come. And you might have a good idea of where you think those impacts are going to be, but until you really start trying to use this capability in a real business sense, sometimes those scenarios don't come to the surface. So it's a great way to highlight those impacts. Like I said, you might not necessarily solve those impacts in a POC, but a learning from a POC could be, actually, if we do deploy this capability, it has an effect on a process or a set of processes that we have. That's a really good learning. And so that's why I go back to my kind of opening comments around what do you mean by success or failure? A solution can fail, but if you've learned that a working solution would have a big impact on a process, that's potentially a really valuable learning. So it's really interesting to make sure that up front you're clear about what these outcomes and goals are. What does success look like? And it isn't necessarily the obvious things. The final one on the left is really important, and we see this a lot, and it's all about gaining buy-in, gaining support, overcoming any kind of preconceptions and fear that there might be about AI. We hear a lot around, concerns of AI is going to, displace people's jobs, or AI is going to take away decision making from people, or AI, masks accountability and causes issues that way. And by doing POCs, it's a really good way to kind of dip your toe in the water and start, showing people how AI would fit into the business and how maybe the negative, concerns that people have are not as, not what they think they're going to be. And so it's really helpful to expose people to these proof of concepts, show them what's being done, show them how the technology is being evaluated so that you can grow that support. Were you able to move that POC into a more of a, production level capability, you've already got people who are on side. And that can be people at very senior levels who are going to be asked to fund and support these deployments, but it is also down at the grassroots level where people are maybe, scared about the impact of AI on their jobs. If you've involved them in that POC, or if you've exposed them to that POC, it's a really good way to start building acceptance at very early stages. Don't wait until you have this capability that you're just going to turn on and deploy to people. It's a great way to involve people very early on in the process. So we see a whole range of different, outcomes and goals around proof of concepts. Really not just about the technical capability, although it is tempting to start there. And the key learning is really make sure you're really clear up front about what the POC is and what it isn't, because otherwise you can end up with this sprawl and it rapidly gets out of control. So be really clear, identify what it is you're trying to achieve and communicate those things. When it comes to phases, again, we've narrowed it down to 5. There could be more, there could be less, but typically, there are stages around, again, confirming what the opportunity is. What is it that you're trying to prove with this POC? Really important to characterize the problem that you're trying to solve, and very importantly, understand data. Do you have the necessary data to make that POC a success, or is it something you're going to have to go and fix before you can even get into POC? Data we've talked about as a really key tenet of AI projects, and POC is really where it first gets exposed. If you find that you can't run a POC even, that's a really good sign that you just don't have the data to take something into production. So data is almost the homework that you have to do. And then there's a big piece, obviously, around architecting and deploying a solution. And I'm going to spend a little bit more time on that in the coming slides. So I'll come back to that one. Very important, obviously, to evaluate the POC once you've finished. So when you concluded the POC, could you do what you thought you would be able to do? And even if you couldn't do that, can you see a path to where you could do that? So how do you evaluate the POC relative to the value it's going to bring to the business? Really important, of course, to weigh up not just the business value that's possible, but what's the investment required to get there. So you might prove that you absolutely can do the thing you thought you could do with AI, that you can absolutely get to this capability, but actually that the cost necessary to get there may outweigh the value that it brings. So really important to kind of weigh up, can we do it with, should we do it relative to business value and other things. So really important after the POC, be clear to evaluate based on those metrics you set forth up front about what is it you're trying to achieve. And clearly think about how you would take a POC further than the confines of that POC process. So once you've got to a stage where, yes, you think you've got a capability, and yes, you think it's valuable and worthy of further investment, good to understand how would you do that? How would you take it beyond the confines of that proof of concept? How would you start integrating that into business processes, formalizing some of the things that you might have done a little bit ad hoc for the POC. So these are typically some of the phases and the outcomes that we see. And really, I want to focus on the kind of bolded one there about architecting and deploying the solution. And typically, again, if we can simplify this down to just a few steps, when you're looking to architect that AI capability, so let's say it's an image recognition problem or a prediction problem, typically there are common stages around identifying the data set you're going to use, as I've mentioned, importing that and getting it into a format that's usable. And then there's this kind of iterative cycle of building models, training, getting that model to the point where the accuracy is what you desire it to be. And if you recall from a previous session, we started introducing this concept of a neural network relative to deep learning. And specifically to a deep learning problem, that kind of building a model and training is all about, defining and adjusting this neural network topology and how many layers there are and what the weightings are until you're getting that desired accuracy. And, that's clearly can be an iterative, or it is an iterative process, and it can be very lengthy and time consuming. And you might decide that in a proof of concept, that might be the thing that you're trying to prove, that you can do that and that you can architect that way, and that's absolutely fine. There may be instances where actually you're not really interested in testing that capability yet. You're trying to identify whether a capability can be plugged into a business process and can be used. And in those kind of circumstances, the effort required to iterate around this cycle again and again and again, that potentially is a tough thing to fit into a proof of concept if you're time constrained or resource constrained. And so what I'm going to talk about a little bit more today is how can you accelerate that piece of the proof of concept, because it can become overwhelming, right? How do you bring that time down? How do you accelerate that time? How do you leverage capabilities that are out in the market already to enable you to still run an effective POC, but not, over-index on the building and training piece if that's not what your focus is. So I'm going to focus in on that today, give you some examples of how other people have done that, and then we're going to pass on to the other speakers to talk about their perspectives. So I'm going to introduce a piece of technology Intel has called the OpenVINO toolkit. And there are some terms on this slide that may be a little alien to people. That's okay. I'll try and explain this in a fairly straightforward way, and then I'll show you some examples. And essentially, OpenVINO is a tool that has really three key aspects to it. Two are shown on this slide, and the third I'll come to next. The first is something we call a model optimizer. And a model optimizer is technology which will take a deep learning model that has been trained, and it will take it from any number of framework tools like TensorFlow, Caffe, MXNet, some of these terms that you'll see on the left-hand side. These are all kind of industry standard tools for building deep learning models. And it will optimize it and convert it. It will optimize convert for what? For different kinds of hardware platforms. And really, this is, our goal of this particular product is to give people the freedom to train a model in one place and deploy it to any number of different places in an optimal fashion. And really, this is the point of this is to explain, try and minimize efforts around some of that optimization to accelerate those, path to POC results. You don't want people to be bogged down with trying to optimize code if there's a tool that can do that for you. I'm not going to over-index on this particular piece, but just to make you aware, the toolkit has this capability to optimize models for performance and to then deploy them on all different types of hardware platform. I think I may have talked in the past about some of these devices that we have. So this is a little thing called a compute stick, and this is a device on which you can run a full neural network. This would be the fourth box down on the right-hand side, that neural compute stick plugin. So OpenVINO gives you the ability to take that model that you've designed and deploy it to any number of pieces of hardware, including those. A little interesting bit of news this week is there is apparently now one of these devices orbiting the Earth. There is a satellite that's been put into space to monitor weather patterns and cloud coverage and things like that. And the AI capability has been added by the inclusion of one of these devices. So not related to OpenVINO specifically, but I just thought that was kind of cool to mention. So OpenVINO is really something aimed at developers to help them optimize their code. But let's say you're in a proof of concept phase and you really want to minimize the amount of time that you're spending on developing code from scratch and building that up from a blank sheet of paper. The other thing that comes with OpenVINO is a number of pre-trained AI models. As I mentioned, that process of training a model to the point where it's sufficiently accurate for your use can be quite time consuming. You can find yourself in a situation where you never reach the accuracy that you need. And if your proof of concept is gated, as I said, in terms of resources or timing, that can be kind of unhelpful. So OpenVINO comes with a load of open source, pre-trained AI models that are available to anybody to use. And the idea is that we're, again, just trying to remove the effort required to do that piece of the training. So we're providing a load of use cases, or rather frameworks and models for common use cases that people can just adopt and use immediately to just try how would that capability fit within a business process flow. And the list here is being added to all the time, but to give you these examples, this is what's available today. You can see how some of those applications might be used. The one at the top right-hand corner there is what we call road segmentation. So this is the ability for a camera on a vehicle to tell the difference between a road or a hard shoulder or a sign or a cycle path. So there's one example. To develop and train a model like that would require a huge amount of data and time. Now, if you want to use that capability, but your proof of concept doesn't give you that time to develop that model, we have those models already available. And you can read for yourself a number of different examples here, everything from sort of face and gender recognition, text recognition, all kinds of common use cases that can be applied. We also provide, in addition to the models, a number of sample applications that use those models so that you can see how you would take a model or a combination of models and deploy them into a solution. So if you look at the images there on the bottom right-hand side, an interesting one on the bottom left is what we refer to as a smart classroom demo. And this demo actually takes multiple of the pre-trained models and combines them together into an application. And it can identify, individual students in the classrooms, as you can see in the picture. It's identifying the faces. it can differentiate between different faces. So it will know that the faces refer to different people, and it can re-identify them if they're then sitting in different places at different times. It can also identify actions. For example, if someone has stood up or is sat down, if someone's raised their hand, it can tell whether the people are looking in the direction of the front of the classroom. And it's doing that with a combination of the models that I showed on the previous slide, like action detection, face detection, gaze detection, and so on. If you can see in the top right-hand corner, that's gaze detection. You can see that the image is able to tell in which direction those people are looking. And so we give you sample applications that bring together some of those capabilities. And again, the idea is to accelerate that part of the process, which is training a model and building it into an application, and allowing you to focus instead on what's the implication of that capability to business process. Now, you might decide that the point of the POC is to learn how to do some of those things, in which case these are a great learning aid, but maybe you then want to use them to go and develop your own models. But the idea is, give people a suite of capabilities that they can tap into to remove that piece of the process if that's not what they want to focus on. And to give you an example, we've had customers that have taken just one example, the gaze detection. So this is, being able to tell which direction a person in the video or an image is looking. And we've had people take those ingredients and turn them into any number of proof of concepts or full solutions, including, is a driver keeping their eyes on the road, or are they looking at the radio or their phone? The system will be able to tell whether they're looking directly ahead. We've seen people use it to look at which direction are shoppers in stores looking, what part of the displays are attracting people's attention. Are they looking at the middle of the shelf? Are they looking at the top, at the bottom? Is a particular piece of point of sale material really attracting people's eyes? So we've seen them used in that way. A similar one to vehicle monitoring. We've also seen in industrial and manufacturing. A lot of times people are operating a very heavy, dangerous machinery where it's very important to keep, attention very focused. And so again, the machine can look and, take action. When someone looks away from the piece of equipment that they're monitoring, you can then take the decision, well, I'm going to hit the emergency stop if someone does that, or I'm going to sound an alarm to make them look back on the equipment. What you do with that information is up to you, but here's a capability that will allow you to tell in which direction someone is looking. And a variation on a theme of the shopper attention monitoring, we look at how effective are advertisements at gaining people's attention. Are we keeping people's attention with adverts? Which adverts are performing better than others? All of these are made possible through these building blocks of gaze detection. So the idea here is, again, just reduce the effort required to build some of those capabilities. And, because I'm feeling brave, I decided I was going to show you what some of these things look like actually working. So let's keep our fingers crossed. I'm going to stop sharing my slides for the moment, and I'm going to show you what some of these demos actually look like. So you'll see me for the moment. I'm going to turn my camera off because I'm going to use the camera for other things. And what I'm going to show you to start with is a face detection demo. So bear with me a second. You should now be seeing me again, but this time with an overlay that's identifying me as male. It's making a horrible guess at my age. I don't know why that is. The lighting must not be very good. And it's also making a guess at my emotion. And you can see the little box at the bottom is giving a kind of a chart of how confident it is that that's my actual emotion. So if I smile in a big way, the odds of me being happy go up. If I look angry, you can see that the emotion tracker is changing alongside the changes in the video. So this is, free code. This is a number of different models all combined into one. So in here, there's a face detection model, which is the blue box. There's a gender detection model, which is, as you can see, identifying being as male. And there's an emotion recognition model. And the application is bringing those three models together and presenting them as a display. So there is one example. I should also have said, I did wonder, let me just bring that one back up again. I did wonder how accurate this was relative to face-like objects. And so relatively topical. It clearly represents that this is not a face, this is a pumpkin. But you can see the model has been trained obviously well enough to know that I'm a real human, and although that has face-like features, that's not identified as a face. So there's an example. We can also apply that same capability to videos. So that previous one was obviously looking at my webcam. Here's another example, and apologies, the video might be a little bit choppy over Zoom, but I think you'll get the impression. This is now operating on multiple faces. This is a video that we just pulled off of YouTube. I would argue that this is really strong evidence of the power of plastic surgery, because the age estimates on this video are wildly optimistic, I would say. In some cases, I don't think Jimmy Carr has been 35 for a number of years. But you can see, again, this gives you the capability to start analyzing video, in this case for things like emotion and ages and genders and things like that. That capability is available to you now. You could build this into a POC if that supported your goals and would take away the time necessary for you to develop your own models. So there's another example. We have other capabilities such as let me show you the gaze detection working in real life. So here again is the feed from my camera, and you can see that as I look in different directions, the blue lines there are indicating which way I'm looking. So again, you could apply that to a video. You can apply it to a live feed from a webcam. But again, very straightforward. Any one of you could download the code required to run these, run them on the laptops that you're watching Zoom on. This is not performance intensive stuff, and it gives you the ability to get this up and running quickly. Those are obviously a lot around faces. Another example would be around text detection. So again, I'm going to fire up this next demo. And again, you'll see me for the time being, and obviously there's no text in frame right now, but if I pick out an item here and I hold that up to the camera, you can see that it's reading the text from that box and overlaying it on the image. Now, obviously you could choose to take that text and output it to a file, or to input it into some other application. We're currently displaying it visually, but what you do with that data is up to you. So you can see that's how that works. Not limited to text on boxes, text anywhere will be recognized. So again, all of these capabilities are available to you. Now, it can be interesting if, depending on the domain that you're looking to use that application in, you may find there's a bit of tweaking needed for the models. So again, if I share with you here, here is a picture of medical notes. And this is just an image. There's no AI associated with this yet. But this is obviously handwritten medical notes, maybe from a medical student, something like that. If I then launch the AI version of that, that's going to attempt to read those notes, what you'll see is that it's made a good attempt at identifying the words that are on that written page, but you'll see it's not getting it 100%, and there are some words that are potentially not recognized because the model just hasn't been trained on that vocabulary. So this is clearly a medical image. Pulmonary is perhaps not a word that it was trained to recognize. And so you might find that there's an element of slight retraining needed to some of the models. And I know that some of the speakers later on are going to perhaps talk about how they've done something called transfer learning, which is taking a capability that exists and then not starting from scratch, but maybe tweaking it to fit better into a slightly different use case or model. So in this case, it might be that you take a model that already knows how to do text recognition, but it just needs an element of retraining to work within a slightly different domain. But the point again here is these are all available to you to use at your will for POCs or in terms of building production applications. These are all available, freely downloadable, and they're updated on a regular basis as well. So you'll find that models are added all the time, accuracy is improved all the time, and so this is kind of an ongoing exercise. And I'm going to finish with one final one, which requires me to stand up a little bit. So this is human pose detection. So you can see that in this case, the camera is looking at me and is identifying, the elements that make up my body. So as I move around, you can see that it's tracking my movements. So again, we've seen people using this to identify, for example, correct lifting posture. So are people lifting with their backs, or are they, kind of bending over and potentially causing injury? We've also seen people using it for exercise and physiotherapy. So for example, if you're a physiotherapist and you're treating people who are being rehabilitated, one example was actually with Parkinson's disease. One of the tests apparently with Parkinson's is can you bring your fingers together, and how do you move? And the challenge is that that's a very subjective thing. A GP or a physician might score you out of 10. They might give you a 7 out of 10, but the next time you see a doctor, it's a different doctor and they interpret it slightly differently and they give you an 8. Well, does that mean you've improved, or does it mean the second doctor was just scoring you more generously than the first? If you can standardize that with some kind of computer vision or AI, you get a lot more standardized measurements. So again, we see lots and lots of applications of these very basic building block capabilities. But the idea is that it kind of enables you to get to that innovation and creativity part, and how does it plug into your business process, rather than necessarily getting bogged down on that potentially very intensive training and retraining piece of the puzzle. So hopefully that's been of some interest. I wanted to just break it up and be brave and show you some demos and take a break a little bit from some of the slides. So I noticed there's a few questions on the chat, which I'll try and respond to in a second. But Katja, I guess we're probably at the time when we need to hand over to the next speaker.
Thank you so much for being brave, Chris, because I thought that was, the breadth of purposes that we can use this for. I mean, I see Joe Baker from AstraZeneca sharing with us that an apprentice of hers is using similar emotional recognition feature to create a quiz for neurally diverse individuals who struggle to gauge emotions to others. The idea is that they can practice in a safe environment without fear of outcome. I mean, the breadth of opportunities that you can use this for is really great, and thank you for being brave of sharing that with us.
No worries. Well. In fact, there's one final example. There you go, of another emotions video. Admittedly, these people are being fairly unsubtle in their emotions, but it's extremely powerful. I think when you look at all these very sophisticated AI use cases, when you break it down to the core building blocks, actually a lot of the time they're quite simple building blocks. So, okay.
Yeah, there's one question from the chat that I'm going to ask you from Commenta. Does the text recognition work across all languages?
It depends on what you've trained on. So in this case, I could dig out, I'll do that while the next speaker is on, in terms of which language that particular model is trained to support. But in theory, it's just a basis of what it's been trained to do. In our case, I think it certainly does, but no reason why it can't do that. I'll go and check the list.
Okay.
I noticed there was a question about waste and trash recognition. I am not aware of any offhand. That was a private message I'll respond to in a second. But
and we'll all have some more opportunities for Q&A after the second speaker. We've got a break and a Q&A, so we can have more opportunities to ask Chris some questions. I'm sure there are quite a few questions still left to be answered, but we'll perfectly do that when we have our break after the second speaker, because we are going to our second speaker now, which is Robin Meehan. Robin is the founder and CTO of Inner Wisdom, and he is our second speaker of today. And Robin, whenever you're ready, the floor is all yours.
Great. Okay. Thanks, everybody. That's a really great lead in, actually, to what I wanted to talk about. So I wanted to spend a bit of time just focusing on the execution side of getting to a successful proof of concept. So I'm the CTO and co-founder of Inner Wisdom. I'll explain a little bit about us. So we're an Amazon, very much focused on Amazon Web Services. So that's the platform we use for all our machine learning and AI work. So we're an AWS Premier consulting partner. We're all in on AWS. Essentially, we do one thing really well rather than spread ourselves too thin across other hyperscalers. And obviously, we're working with the market leader, AWS being having the largest market share by a very long way, and a great platform for doing what we're doing. So we work in the area of, we're really interested in, though we're talking about AI and ML here, our focus is around helping our customers to exploit every aspect of their data using analytics and artificial intelligence. So we're really interested in the execution and the business outcome, and the AI and ML and sort of descriptive and predictive analytics are the kind of journey to get there, the weapons of choice to get there. In terms of geographies, we're across the whole of EMEA, so we've got lots of customers in the Middle East and across Europe and the UK. Yeah, that's us in a nutshell. So just one quick bit of bragging rights. So just because it happened yesterday, we were announced as from AWS, Amazon Web Services, as Machine Learning Partner of the Year for UK and Ireland. So hurrah! Don't often get to you got to sort of brag about your successes, right? Because our team worked really hard to deliver for our customers. So we were really chuffed to get that award. It's the second year running we've had an award, so it's fabulous. Anyway, so that's the background. That's what we do. So just to position a little bit about how we fit in with Amazon, which I've kind of covered, but also with Intel. So as I mentioned, so we're working in the advanced AI and ML, but also so the data lake and data availability. So the data of ETL or ELT, extract, load, and transform, and the descriptive, so kind of classic sort of rear view mirror reporting and visualization. So business intelligence as well as predictive and prescriptive, all running on cloud platforms. So to do that, we use all the goodies in the toolbox from Amazon Web Services, which is a huge range of things, from kind of raw virtual machines on EC2. We use SageMaker as our machine learning platform of choice. All the stuff that we'll be going through today is all generally on SageMaker. So that's where we train models, but also we deploy them into production. But then also Amazon Web Services and the other hyperscalers have platform as a service offerings. So for example, personalized forecast, fraud detector, for example, various services from AWS that allow us to have, if you like, high level abstractions above the machine learning models that we want to use. And so text extraction and many of the things that have just been shown, in fact. So we use all those services on AWS. And of course, those are underpinned by Intel, right? So we're using different instance types, so C5s, R5s, T2s, T3s, M5s. We use those all day, every day for training models. So Jupyter notebooks and training models on the cloud. So it's the bread and butter of our data science team and our DevOps and production teams. And it allows us to control our price performance trade-offs in terms of how much memory versus I/O and disk and so on we need, and CPU obviously. And then when it comes to deployment outside of the cloud, so that's training and hosting inside cloud. When we want to deploy outside the cloud, then we use the OpenVINO toolkit that's just been talked through, obviously deploying onto Intel hardware at the edge, so in disconnected environments or where you want very fast inferences and you don't want a round trip to cloud and back. So that's how we kind of fit together with AWS and Intel, who we work very closely with. So just a quick bit of scene set about why we are where we are, as in why we care. So there's a few things that have changed in the last, say, 5 to 7 years, I guess I'd say, which is why InnoWisdom exists, right? Why we founded the business. So starting on the third column there, we all know that the kind of scale of data and the speed at which data is being created and it's arriving, so the velocity is growing at a kind of mind-boggling rate, frankly. That has led to so on the column just to the left of that's led to an explosion in the kind of research effort and energy that's gone into AI algorithms of the last, say, 5 to 7 years, very much driven by the kind of hyperscalers. So the big cloud providers, and that's led to a kind of flywheel effect where the sophistication of the AI algorithms and the stuff that you've just seen lots of great demos for. I mean, I never get tired of seeing those kind of demos because they're always still mind-blowing. Just the what could be achieved on relatively, the training of these models is very compute intensive. The actual inference time, you can run them. We're used to seeing these things on our phones, mobile phones, which are still pretty powerful devices these days. But the actual inference costs are quite cheap comparatively. So the sophistication of the algorithms is incredible and advancing at a very fast rate still. Just a little aside there. So there've been a number of periods in time called the AI winter. I'm not sure, maybe 2 or 3, depending on who you ask. But one of our employees has got a PhD in AI from back in the 80s, I think. 80s, yeah, around there. And so, and there's been periods in time where there's been a big explosion in kind of AI, so-called expert systems, as it would have been called then. And then it was kind of like a really hard place to get a job afterwards. And it's been a bit of a sort of in vogue, out of vogue, never quite delivered on its promise. Whereas now there is no, the winter is gone. So we're in perpetual spring, I guess, in that we got this kind of acceleration, and it's the convergence of these forces on this slide, really, that the kind of power of cloud platforms has given an ability to accelerate the training and the data acquisition, and then these things all work together and create this flywheel effect. What that means then on the right hand side is that we can now have ML models and AI models that can create very specific predictions and inferences. So the key word, if you've not heard it before, is to use here is about hyper personalization. So a very common project for us to work on is around making hyper personalized, i.e. to the individual, recommendations for how to approach them in a marketing sense, or when their next car service is due, or how to maybe tackle bad debt with that customer. So really specific predictions from ML models on how to personalize the organization's experience exactly down to that one individual and their circumstance. So there's no kind of spam kind of mass market behavior in terms of those business operating models anymore, and still highly accurate. And then back to the left there. So ultimately this gives businesses a really, that they can be way more agile and adaptive, because the models they're using to drive their operational decisions can be can change and adapt to such situations in a much quicker way. One caveat to throw in there is as we mentioned, I guess, a few times today, is around coronavirus. So one of the challenges for us, of course, is that so we're working in this ML space. We use lots of training data, lots of historical data in companies is no longer a good predictor of the future, because that was in a pre-coronavirus era where consumer behavior was very different, and transport behavior was very different, and so on and so on. Economic models were very different. So there is a challenge in the data science community around how to respond, how to deal with the fact that your historical training data is now it's not lost its value, but it's to some extent the value is hidden behind a layer of the fact that the world has drifted significantly. So that's an really interesting challenge. It's like a fascinating data science area to work in, and we've deployed various strategies for customers to, if you like, compensate historical data to allow us to still use it in future models. In terms of where the use cases are, the use cases and the applicability here is kind of mind-blowing. This has a plethora of use cases, just to pick out a few. So pricing and promotion, bottom right there, around optimized pricing models tailored to the individual. And we've worked on, for example, using machine learning to learn pricing behavior, customer sort of, if you like, demand elasticity curve behavior, and then using that to run what if scenarios to say, okay, if I change my pricing like this, what customer volume decrease do I see? But do I actually make more pound note margin, even though I've actually lost in terms of sales volume a little bit, but I might actually make more profit. So it's like tuning that supply demand elasticity curve. Other areas like anomaly detection. So I think on here we've got fraud detection, special case of anomaly detection. It's a very specific sort of machine learning set of algorithms. And so we've worked in money laundering detection, for example, is a great example of that, where the fraudsters are trying to kind of hide amongst the normal, but they still need to get quite a lot of money through the accounts. So there's things that you can detect, and also detecting on the customer experience side, detecting transit time for packages. So how quickly, when will my package be delivered? I'll talk about that a bit later on, and supply chain and so on. So there's a huge range of opportunities for organizations, and I'll touch on this as we get into some of the proof of concept stages and the pitfalls that flow from that, because there's a lot to choose from. So prioritizing it is very challenging and important. And just to very quickly touch on where consumers see the power of AI. So it's just a survey from the Institute of Customer Service. So it's interesting that the consumer viewpoint on this, there's a speed dimension, there's a convenience dimension, there's a cost, like a cheaper cost dimension, And there's that hyper personalization point that I mentioned earlier. So consumers are expecting all these kind of benefits to flow out of what we in this room do over the next, say, 2 to 5 years in this area. Okay, so that's your mission, to meet those expectations and exceed them. In terms of data sources, the data sources that we can apply these kind of techniques to are, again, pretty endless. And I guess with the avalanche of data that's being generated and captured, both human and machine data, then there's a huge range. The key points I wanted to make here is, so we work in, and you will work in, you'll see structured data, so sort of database tabular data is common. I'd say more than half our work is in that area. So that's the kind of predominant type of data source. Well, mainly because we work in the kind of corporate enterprise space. So there's lots of latent data within organizations that's not being fully exploited. And then there's unstructured data, which is text, documents, video, image, so audio and speech. So contact center recordings is a classic one. We've got sort of the speaker and the caller and the contact center agent on the left and the right channels, and converting those from speech to text, and then using those in your NLP models, natural language processing. And then in between structured and unstructured, you've got semi-structured data like JSON files, XML files. So these are often highly hierarchical, so kind of like a halfway house, sort of structured data, but held in a semi-structured format. So it's a very common data source that we work with and comes from the source systems. So the key point to take away here is that the value in the applications and business models that we build, it generally comes from the combination of these data sources. So not one data source. It's not take one data source, produce some value, pat yourself on the back. It's actually take data from, say, 2 different data sources, 2 different systems in your organization, and you might have good analytics on this one, good analytics on this one, but it's the combination of those, more than 2, and then building predictive models across those. So it's the insights across the kind of holistic picture of data that you hold about your products or your customers or your transit patterns or whatever they might be. That's where the deepest insights and the real differentiation comes from. So key point. Okay, so enough preamble. Let's get on to the proof of concept side. So the first thing I wanted to just tackle, so again, picking up a little bit on the earlier point, was around why we're even doing a proof of concept. So there's a few good reasons. So one reason is to get a win on the scoreboard. So in some organizations, there's lots of machine learning and sort of AI skepticism out there still, quite rightly too, right? But for good and bad reasons, and just some fear. So I think just getting a kind of win on the scoreboard and sort of demystifying and taking some of the fear out is of it in itself of value. But it also then unlocks the next step. So once you've done that first kind of baby step, then the future that seemed very unclear as to where to go next then becomes way clearer. So you'll be like 100 times clearer for your next decision after you've taken a small sort of measured investment step. And people often say fail fast. So I guess I like to focus on succeed fast, right? So a strapline for us is around discover first and invest later. We want to minimize the initial investment to learn or prove or test a business hypothesis, and then pour some fuel on the fire and squeeze the business value out of that once the concept is proven. So it's about succeeding fast. I think that something that really strikes me about the proof of concepts that we run with customers is that they do actually, they quite rarely fail, meaning that I suppose the business hypotheses that we're working on are generally very valid and well understood. So, which a crude way of putting that is, our customers generally know where the treasure is buried, right? So it's not because we're at the early stage of AI adoption and machine learning in organizations and in public sector. Then there's a lot of value in the data that's just not really being leveraged. So there's lots of low-hanging fruit out there, I guess is what I'm trying to say. And so generally, if you have a good prioritization process, which I'll come on to, then the stakeholders you're dealing with in these organizations, they know like where the gold is buried and what to go for. So they rarely fail if you go through a good prioritization. So getting into it, what we've done is we've wrapped our learnings from the years of doing this into a simple roadmap to go from ideation, so for what's the ideas, what's the hypotheses that we have, or where we think the gold's buried, all the way through to reality and business and organizational impact. So I'll step through each of these on a single slide, steps 1 to 5. So 1 to 5 are the 5 steps of the proof of concept, and then step 6 is we're in production. It's an ongoing process, and and then we come back and do the next one and refine our models and improve and squeeze more value out of the system and tackle other use cases. So just to step through these at a very high level, then I'll go through them in a bit more detail. So the first one is around prioritization, and us fundamentally having a terms of reference for what you're doing and why you're doing it and what success looks like. So I'll dig into that in a bit more. The second step, stage 2, is where the machine learning happens, the discovery work. Then we move on to delivery and playback. So this is really crucial. So it's actually really just the wrap up, the evaluation as described before, the evaluation of what you've done, but really, really important. So I'll dig into that. Then we have the acceleration, so basically proving the minimum viable product. So getting into a production footing and validating probably the non-technical aspects, if you like, of the business proposal that you're taking through this process. And then stage 5 is moving to full production, and adding all the kind of production and operational hygiene for something to live with it for the long term, to keep it robust and secure. So I'll go through each of these in detail. So the first stage in this journey, stage 1, prioritization. So I can't overstate how important this is. So we've seen lots of anti-patterns with customers here. In fact, I'll come on to this a little bit later on in terms of where some of the pitfalls are. But here's an example from a real customer. So what we're doing here is we run a prioritization workshops, and what we're trying to do is we're brainstorming, if you like, all the ideas, which generally the organizations generally have way more ideas than they have capacity to execute, right? Almost exclusively, always the case. So what this graphic represents is we have business value across the bottom, and we have how feasible it is or how deliverable it is, so how hard it is, on the y-axis. And obviously the ones you want to focus for are the top right. Those are the ones that have the highest business value, and are most deliverable, have the highest feasibility, and they feel like the lowest delivery risk. One thing to bear in mind here is that there's which is represented on here actually with the little red, amber, greens, is that there's a benefits realization period as well. So something might have high value, but it might be a kind of 2-year project, or it might be a 1 month or 2 month project, right? So the time to value is also, so value is not, you've got to consider, you've got to define what you mean by value in your organization and what matters and for your particular business strategy at that point in time. So time to value might be, it's a really important consideration. It might be that you're actually after quick wins at the moment, or kind of longer term strategic wins. Ideally, what you want to do is put a pound note number or euro number against each of these opportunities. These are actually very small ones. I wouldn't recommend those numbers necessarily. To help you kind of quantify. So you've got some definition of what low, medium, and high means. Often you have to stick in this kind of low, medium, high approach. And it's actually easier to compare, well, is this one more valuable than that one? So it's easier to kind of compare them, to sort of use a comparative approach between opportunities. But then ultimately, if you can put pound notes on them, that's even better in terms of kind of revenue upside or cost reduction. So that's phase 1, and I'll cover some pitfalls in that a bit later on. So the output of that phase is a terms of reference, what we call a target opportunity definition, which is what am I trying to deliver? What am I going to take through this process? I'm going to pick one of those. What am I going to take through this process? What data am I going to use? Using what tools? Who's responsible for it? Where do I get the data from? Can I get the data? Is it of sufficient quality to meet my needs? Probably. But crucially, what KPI or CSF am I trying to track here? So what business KPI am I trying to move at the end of this initiative? Then we move on to this stage 2. So this is where the machine learning happens, right? So one of the key challenges in these machine learning projects is just understanding, getting an intuition for the data and the way the data is structured. Humans are appalling at working beyond, 30 data points and they're also appalling at working beyond 3 dimensions. Machine learning algorithms are really good at those things, right? So one of the challenges we have as humans is to find ways to gain an intuition and kind of we use visualizations of really complex combined multi-dimensional data sets. Here's one from a real project to help us get an intuition for what structure and patterns are hiding in the data that the machine learning models have learned. But is that what we wanted, and how do we understand how it's making those inferences? So this is an example from a chemical process yield optimization use case, and you can see there's an inherent improvement in yield depending on how we set the other parameters for the industrial plant. But it's also a great articulation of how really noisy the data is. It's really hard to get. You can get numeric measures, quantitative measures for how noisy or poor the data quality is, but there's nothing like actually seeing a plot and dragging. This is being dragged around by a human here, dragging it around and zooming in and zooming out and just exploring the data as well. It's also a great tool. So there's another key thing here is we want to play back on a weekly basis to our business customers. And because they understand the data better than we ever will, because they live in the business usually, they're kind of living and breathing it. So it's that kind of meet in the middle, and we want to use these kind of tools to help visualize what. And usually there's findings that come out of this that weren't obvious to the owner of the data in the first place. There's always surprises, which is a great part of the process that I enjoy. There's more I could say around data quality and so on there, but I think I'll move on for the interest of time. So then we move on to delivery. So now we've done our, say, 3 weeks of data science work, usually a 1 week sprint metaphor, so 3 iterations with a playback with our business stakeholders and discuss and share the data results with them after every week. So now we're at the end of our time boxed hypothesis test, okay? So our hypothesis that we defined at the start, which is, okay, with this data from here and here and here, I can reduce customer churn by 10%, or I can increase sales by 5%, or I can predict the inbound call in my contact center and diagnose and say what it's about, for example. So so here's a whole bunch of different metrics you might get out. So I show the metrics that we get. This is what comes out from the data science universe. So on the top left, we've got accuracy of our TensorFlow model, our deep learning model as it's over training epochs, and how it's heading towards kind of 96% accuracy. Bottom left is a classic way of measuring the accuracy of one of our binary classifiers. So it's like, telling between two classes and where the false positives and true positives are. And then at the top in the middle there, this is a multi-class classification problem. So it's a similar approach. This is using an approach called a confusion matrix to show how well we're predicting labels against the true labels. So ideally, you want everything to be, you want zeros in everything except the diagonal through the middle then for a perfect model. But these are all great, and these are all kind of technical assessments of what a great data science job we have or haven't done, right? But what really matters, this is the key takeaway. What really matters is those are just metrics, useful metrics. But the key question is the business value that we can now derive if we had this model in production, is that significantly greater than the cost of putting it in production, the cost of operating it? Okay, so if the business value is much greater than the TCO, and we'd be looking for like a 10x ideally, then that's the key point. And so a key takeaway for you again is, some models can be 60%. So a question I get asked all the time is, what model accuracy can we get or should we get? And so I'd say for some of our sort of standard scikit-learn type models, maybe sometimes an accurate of 60 or 70% is really business impactful, because it's better than flipping a coin and suddenly you're making smart decisions in your business operation that before were completely unprioritized. And so sometimes a low accuracy can still be very significant in a business value sense. And sometimes you need a really high accuracy, like on phase detection and so on, that we'll be looking at, and it's already been demonstrated. Obviously, you want it to be reasonably accurate, otherwise it's not really useful at all. Okay. So that's really key. Then we move on to the MVP deployment, so the accelerate phase. So here's just an example, AWS, Amazon Web Services architecture for, this is actually for deploying OpenVINO models at the edge, which give a couple of demos of, very similar to what you've seen before in a moment. So that the key thing we're trying to test at this phase is we want to spend the minimum amount of money to get into production and test it in a real production scenario. Production deployment can mean lots of different things. So sometimes it can just be a paper report. So sometimes the output can just be a paper report for the CFO once a month, still using obviously predictions, right? It's still inference based, but that can be very insightful. So it can be just extra information for the CFO to understand, to steer his business in terms of risk profile or debt profile or investment, the investment risk across his portfolio, for example. So the output, the productionization, is literally give them a report once a day or once a month. Okay, and so the production implementation of that is trivial in a kind of implementation sense. And some implementations could be very like embedded into customer systems, like integrated into your contact center solution, for example. So so this can vary quite a lot in terms of the effort required here, but the key point is to keep it, the clue's in the name, MVP, right? It's minimum viable product. So do the minimum you can to prove the business value can be extracted. So we're really moving here. We've done a proof of concept now. So we're out of the C. We're not doing a proof of concept now. The concept has been proven. We know we can predict this to this accuracy. This KPI we can predict to this accuracy. That's not up for debate. We've done it. Look, the question is now, is a proof of value. Can we get the value from that? So let's now move into a POV rather than a POC, as we would call it. And it's testing the, as I say, that the business hypothesis actually holds water in a kind of quickest and cheapest way. And then, assuming the MVP is successful and we're all slapping each other on the back and we're fabulously well received, everybody's happy, then we want to roll this into production in a very like a long-lived and well-maintained and supported way. So then we spend the extra money, the extra investment, because we know it's justified for productionization. So this is the extra monitoring, alerting, the automated model retraining in production. So that step function flow from AWS on the right-hand side is an orchestration of retraining the model, say once a day or once a month, which we do for many of our customers, because the world is always moving on. So the models always go stale, or should I say, the world changes around them, so the models drift because the world's drifted. On the top left there, and the two graphs. So it's really important to track. When we're doing these kind of high performance models. So here we're making over 1 million inferences, predictions a day through an AWS SageMaker endpoint. We want to track those prediction calls, those inferences, because they're feeding a mobile app, or actually some of these are going to WhatsApp for delivery prediction and so on, delivery time prediction. And we want to track how long those inferences take. So the average net time is 125 milliseconds for each set of predictions. These are actually combinations of models, in fact. So these are really important operational metrics to track. We want them on our dashboard. So in this case, an Amazon CloudWatch dashboard, so that our operations, our DevOps and our ML ops guys can keep the models running clean, good, in production, understand when they need to be retrained, automated retraining. So this is all the DevOps universe, essentially, but really key. And then supporting them for customers going forward, which is what we did. So then just to wrap up, so once you've done those 5 phases, so prioritization, do the machine learning discovery work, wrap up the results and prove a business case, basically produce a business case, stage 3, and then do that MVP deployment in stage 4. And then when that passes that test, do the heavier, if you like, productionization and operationalization. And then once you've done that, then it's rinse and repeat, because each of these successes then breeds another question of, oh, we could do this and we could do this. And there's other use cases on your prioritization backlog that you can tackle now. So it's essentially embed that and rinse and repeat. So we call that scaled AI. Just to cover now, so 2 more sections to go. I just wanted to cover some of the common pitfalls in that process. So there's quite a long list, I guess I could go through here from our experience, but I thought I just wanted to pick out a few to go through, and then I'll wrap up some demos and we're done. So a few things to call out in the common pitfalls. There's a number of kind of anti-patterns. There's a blog post that I wrote some time ago, which is kind of related to this area, but that's more around anti-patterns if you're setting up your own data science team. But maybe worth a look if you're interested in that area. So things I want to call out is the prioritization step, which I've stressed, but I'll just mention a few more things. To have a method, keeping your buy-in from your stakeholders, not as easy as it sounds, and being full stack. So I'll just go through these briefly. So that, as I mentioned on the when we're prioritizing where to focus our time and building our terms of reference, we call it a TOD, a target opportunity definition. So what am I going to do with what data to get what KPI to move? How am I going to measure success? So there's generally always too much to shoot at. So you want to assess them, as I mentioned before, in terms of business value and impact, as well as feasibility. So that's technical feasibility, commercial feasibility, political. So there may be a privacy barrier, for example, in a feasibility sense. It may not be feasible with the privacy policies you have with your customers, for example. So that may not be a machine learning technical challenge or an algorithmic challenge. Whereas some use cases may be just algorithmically, very kind of hard and cutting edge or difficult with the data you've got. I also mentioned before about the business payback. You need to consider what the time frame is for your payback. So a bit of advice here. If you don't know where to start, I would generally, when you do this prioritization process, what we often find is that there's 1 or 2 or 3 use cases that kind of naturally sort of fit together because they're operating on the same data sources. Just 3 different opportunities, but they're kind of sourced from the same source data. So it often makes sense to handle those as a set, just because it's more, it's economically kind of more viable, easier, cheaper to do. But if you're not sure where to start, I would generally recommend pick two of your complex set, or your set of opportunities to work on, and have one that's kind of a long range moonshot. So it's more of an innovation play. It's probably it's riskier, it's got more unknowns, but the size of the payback, the size of the prize is potentially enormous. It could be a new business line or a kind of radical change, a radical operational improvement, for example. It's a game changer, right? But the time to value for that is probably at least a year, because so it's more of an R&D project to some extent. But if you don't start, you will never get there. So that, and your competitors will get there before you, right? So doing nothing is not an option, but you need to start going down that road, but accepting it's got a longer time to value. And then at the same time, also pick a different opportunity that's got a much shorter time to value. It's probably got less of a huge payback, but it's more in front of you, it's more present, and it's sort of a lower risk, if you like, lower delivery risk and higher certainty to get to that value. So not necessarily do them in parallel, but I think, accept that you've got a kind of 2-horse race type model. Pick a moonshot and pick a kind of safer bet. And the safer bet will give you the business buy-in and stakeholder acceptance, whereas the moonshot is the thing that could be a game changer for your organization. So my key takeaway here is pick your battles, right? A real anti-pattern is to try and do too much, or just let your kind of data science team just kind of meander around the data science universe. Playing with data is generally a great way of getting your data science capability expanded. Spending quite a long time and then getting expanded. Second pitfall, this is in the obvious category, so apologies, but not everybody's doing it, right, is have a method. So have a method, follow it, time box what you're doing. So our method is based on CRISP-DM. If you've not heard of CRISP-DM, it's actually come out of the data mining universe quite a long time ago. Nothing new under the sun, right? So it's all kind of pretty obvious, but it's nicely articulated. And then we've kind of tweaked that and changed that for our particular needs and our learnings. But as I described, our step 1, we have an initial workshop. We produce what we call a target opportunity definition, as you can see there. That's our terms of reference. And then it's like go. And then we have our 3 one-week sprint iterations with a playback, what we call delivery in the 5-stage POC. So the key takeaways here is have a method. Don't be aimless, stick to your method, govern yourself. And then in that method, be brutal with your scope and your critical success factors. Be really brutal so you can keep it to the time box. Iteration is really key. So that you'll see in this method here, there's a weekly playback with the business stakeholders, not the technical stakeholders, but the business stakeholders. Like, this is the data and this is what we found and these are the insights. This is what it's predicting. Is that what you expected? Oh, look, we never sold anything in January. That's a bit weird, isn't it? Or whatever insights come out, because there's always surprises. It's very engaging as well. And as I said, time box it, absolutely crucial. Because one of the challenges with the data science world is there's never an end, right? There's no magic point at which you've got the best model. It's all about fit for purpose and getting value. So another truism, one of my favorite quotes, is just going to be it's better to have a 80% accurate model in production than a 93% model that's just on the shelf and never makes it, right? So get it into production and then iterate. on the higher levels of accuracy. So as I mentioned, getting buy-in is a challenge, or can be a challenge, and so definitely you want to make sure you don't lose your stakeholders. I've mentioned techniques for that, and be full stack, which means you need the DevOps and implementation capability to not just implement the AI ML models, not just that data science part, but also the data and analytics, the data ingestion, and the ability to build the underlying platform to deploy it on. This is often a failure pattern we see with customers, is they might have a data science model, but they can't get it deployed into production. And then just to show some examples, again, similar to what you've seen before. So this is an example we're actually working with Intel and a company called AD-Link. So before coronavirus kicked off, we were looking at PPE in the construction sector. So AD-Link have embedded cameras to run on-prem with embedded Intel devices. So exactly as described earlier, we use the open Vino toolkit to take a TensorFlow model that we've trained using transfer learning techniques to train on our own custom data. So we took custom training data and various techniques there. There's a blog post where you can read more about it on the page. You'll get that in the slides. And there's one of our data scientists doing some beautiful modeling of some construction PPE. And then similarly, obviously a hot topic at the moment, if you Google it, is around medical PPE. So we started with construction PPE, and here's another one of our data scientists, and you can see that if you want to detect compliance in public spaces for PPE, then you need to know when there's a face and when there's a face with or without a mask, right? So this is Arturus just doing that, and some politicians who may or may not soon be in power doing the same things. Famous mask wearer there. Okay, so just to wrap up, in terms of, we've talked through the 5 steps and our offer, if you want to take this a bit further with us. So we have a couple of workshop approaches, one very much focusing on that productionization and opportunity roadmap, the prioritization, the prioritization element that I've described. And then the second workshop is very much more focused on the taking models to production. So getting over that, how do I get a data science model into production? I've got a model, well, I've got a data science capability, but how do I actually productionize that and look after it? So those are 2 workshops that we commonly run with customers, and be happy to talk to you about those if they're of interest. So contact us afterwards.
Thank you so much for that, Robin, for a comprehensive presentation. I am going to suggest that we are going to go to the next presentation. We have, after the session, we always keep the lines open for 15 minutes or so. So we'll have some opportunity then to ask questions. But I want to make sure that Lee also has enough opportunity in our time to do his presentation. But we'll have, after that, we have about 10 or 15 minutes that we keep the lines open, and then we'll have a Q&A with Robin, and then hopefully also with Lee. So we'll go now to Lee Baker.
Great presentations from both Chris and Robin. I was furiously scribbling some notes during Robin's session. So I'm hoping that what I am able to show today is complementary to both Chris and Robin's talk. So I'm going to talk a little bit about our journey as an organization at Selden, and kind of where we focus and how we provide value. I'm going to talk a little bit about the requirements of the businesses that we engage with, and my experience is often, to quote Mike Tyson, everyone has a plan until they're punched in the face. That you do need to be responsive and iterative to kind of changes within your pipeline. So hopefully we can talk a little bit about that. We'll talk about the delivery stages that we see through from POC right through to production, and ultimately how we've seen businesses tackle their KPIs within their ML workloads. Who is Selden? We are a UK-based, London-based startup, and we're about 25 people. We've been ticking along since about 2014. We exist to shape the future by bringing machine learning deployment to life. That does sound a bit like Mystic Meg with a calculator, so let me put some context to that. very early on in our lifespan, we realized that some of the biggest blockers to the successful application and realization of the potential of AI and machine learning were not in kind of the model training aspects, but rather in the infrastructure and production tools. So could I articulate why my model was doing what it's doing? Could I tell you when it was going to stop doing what it's doing? Could I do that at scale? So these were all of the challenges that, that we encountered. And hence, we took the decision to open source our code base and launch our community Selden Core to provide a standard for model deployment. Could we get businesses' models out into the wild where they could make a difference to the business, whilst at the same time providing assurances around scale and monitoring? Happily, we have been able to achieve our goals. Our open source code, Selden Core, is out there. It's used in a number of different organizations' AI frameworks. So everyone from Google, Uber, TripAdvisor, through MasterCard and Capital One are using our open source code base. And the graphic on the lower left shows not only the growing install base that we're experiencing, but also hopefully something that we are seeing as the tide that's rising all boats. We're seeing the amount of nodes that people are running in their deployments is growing. So not only are more people using Selden, which is great for us, but also this suggests that the sophistication of people's ML workloads is also growing. So people are increasing throughput, they're developing more models, they're creating bigger and more sophisticated ensembles. So that suggests a maturity that's coming to the market. To Robin's point about the AI winter, hopefully what we're seeing now is that perpetual spring being driven by more and more sophisticated deployments. And we recognize that we don't exist in the ether. The machine learning ecosystem is vast. And so we play nicely with some of the big technology platforms and marketplaces. So we're part of the Kubeflow ecosystem out of Google. We operate with perhaps the world's most significant open source organization, Red Hat, and their catalog OpenShift, as well as cloud service providers like AWS, GCP, and Azure. And indeed, we're part of the Intel Builders Program, so we're a known quantity at Intel as well. So what do we do as a business? We provide an enterprise solution on top of our open source called Selden Deploy. And Selden Deploy acts as you can think of it as a controller, a user interface for all of your machine learning workloads. Perhaps a little bit easy to say what we don't do. So Robin described how a lot of what they do with Inner Wisdom is model training. The idea of if I show my model enough cat pictures, it will be able to predict the image of a cat or any other kind of myriad use cases where you're looking to expose a machine learning framework to data so that it can make classification or recommendation or prediction. We are not in the training business. Actually, we see that there are many powerful and existing open source frameworks for model training that are out there. And our belief is that data scientists are going to use the frameworks and tools that they're familiar with. And it shouldn't be Selden's demand to move them to a tool that they're not using. So actually, Selden acts as the deployment solution for any framework, regardless of whether that's open source or indeed proprietary. So we deploy models of any type. And this is a screenshot example of our flagship product, Selden Deploy. Like the very biggest organizations, it's built on an open source core, as I mentioned. We've spent many years building out and nurturing that community. Why is that important? Well, the leading organizations that are embedding machine learning and AI into their systems, some obvious examples here with kind of Uber, Michelangelo, and Facebook FB Learner, LinkedIn Pro ML and Airbnb's big head frameworks, these are all they all leverage open source tooling. And so Selden, we want to be that solution for organizations that cannot build out frameworks at this scale. Can we be the Uber Michelangelo for small business? So the other thing that we observe within Selden is that data science is very much a team sport. The average salary of a data scientist is about $120,000. So the nonsensical approach of trying to make that data scientist also your data engineer, also your DevOps person, also your UX engineer, also your project manager is farcical. You should be focusing the skills and effort of your data scientists on the elements of the pipeline where they can make a difference, specifically model training and tuning. Don't try and make them stretch them into roles that they're not fit to, or there is not a skills match, or they're going to end up wasting their time. Robin made an absolutely fabulous point. Data scientists are key functions within any successful data science project, but data science is a team sport. You are going to need to have multiple stakeholders engaged, even at a POC stage project. And so one of the things that we're trying to provide at Selden is a dashboard that engages all of those stakeholders within the pipeline. The requirements from organizations to be able to understand what's going on from a data point of view is crucial when we're providing audit trails and debugging. So GDPR is probably the best example of kind of a database regulation, but the Federal Reserve in the US also require up to 7 years logging and audit trails for machine learning weights. Now, that is significant if I need to be able to roll back to whatever happened on a wet Tuesday afternoon to demonstrate to my regulator or my internal compliance teams. I need to have powerful audit tools in place. And again, that's one of the things that's baked into the Selden platform. And finally, model explanation. This idea of if I'm using a deep learning model, and Chris referenced right at the top that neural networks have many, many layers. They're often non-linear. They can be described often as black boxes. So the interpretation of their outputs becomes crucial for a number of regulated environments. If, for example, I am as a bank, I'm declining a customer a credit loan application, then that customer is well within their rights to ask why. Why am I being declined credit? And if I'm using a neural network to make that decision, it's very difficult to unpick and explain what are the data points that the model used in order to make that decision. And so model explanation becomes crucial in terms of interpreting a neural network. What were the data points that the model used? In fact, perhaps the biggest procurer of AI technologies is the US Defense Initiative, DARPA. And they put as their key priority for unlocking their $2 billion budget for investment in this technology, they put their key priority as XAI, or explainable AI. Can they explain their models? And I'll show you an example here. I've just done a very quick and hackneyed example. I've just dumped some JSON into Selden Deploy to create a load test. And essentially what I've done is I've used some census data, some US census data to predict income. So it's going to predict whether or not someone makes more or less than $50,000 per annum. And now I'm running a Selden explainer over the top of it, and it's going to interpret why the model gave a certain output. So in this example, you can see some of the data points that are in there: age, gender, education, and it's going to generate an explanation. It's going to be a graphical interpretation. So in this example, we can see that marital status, specifically separated, and gender female are the key data points that need to be present for the output to hold. Now, why is that important? Well, that suggests that there might be some bias inherent in the training data. Is it predicting that women are more likely to earn less than $50,000? Does it suggest that there is a skew towards separated females? Then we might want to dig into that and engineer out any bias that is inherent within the data. And having that human interpretable explanation of the models becomes crucial. I haven't introduced myself. So at Selden, often the room contains up to 4 PhDs. So I am very often the dumbest man in the room. Now, far from taking this as an opportunity to sob in the corner for my intellectual inferiority, I use this as an opportunity to ask the stupid questions. And as a result, it means that I'm deeply embedded in the creation of our POC frameworks, because I appreciate that not everybody comes with a high degree of data science literacy when delivering on platforms and projects. So very often when we're engaging with multiple stakeholders across diverse projects, we want to ensure that we are asking all the right questions and understanding the domain specific to the customer that we're speaking to. So I'll talk a little bit about kind of the essential attributes for data science projects, but let me talk a little bit more about our journey and hopefully we can explain to how we got to building out our POC framework. We see kind of 2016 as very much a breakout year. And I won't labor this slide too long because I think Robin made a really good job of it in terms of describing some of the drivers for machine learning adoption. But certainly the things that we saw as essential was kind of the declining cost of compute, the demand for more personalized services for consumers, and the commodification of machine learning and AI technologies. Perhaps the best example, 2016 was the breakout year for a framework called TensorFlow. TensorFlow is now the biggest open source machine learning framework in the world from Google. And it was technologies like this that in combination with the explosion of data availability was driving machine learning adoption. However, even with kind of some of the shrink-wrapped open source frameworks, there are still a number of requirements to ensure that there is assurance around what you're putting into production. 2016, not coincidentally, was also the year that Selden joined an accelerator from Barclays Bank. And this is really where we learned our craft. So hopefully in some of the slides that I will present, you'll see quite a structured approach to POC. Now, our time on the accelerator was anything but. Everything that we were doing was POC. So we learned the hard way in terms of engaging with a big enterprise, how they can steal the oxygen from a startup. Barclays, who I have to say support a fantastic accelerator, really drove our network. Really, it helped us tune and hone our business, as well as expand our investor network. It was an extremely positive performance, but a positive experience, but it wasn't without negatives. And one of the biggest negatives was engaging with business units from across a big multinational bank meant that we had to get to some abiding framework to deliver successful POCs. And so whilst hopefully now what we present is quite a structured approach to delivering these types of initiatives, back then we were being pulled left, right, and center. So business units were all working at different speeds. They were using different technologies. They were coming with very different business problems. And so because everything was a POC, our definitions of POC were extremely, extremely liberal. And as a result, we were getting torn apart. The oxygen was from the room. And these are the sorts of things that can kill a startup right from the very beginning. It can also kill enterprise teams and machine learning projects as well. So whilst I like to present Selden as a very honed and polished beast, this is absolutely where we learnt our craft, the school of hard knocks, as it were. We came out of the accelerator and engaged in a number of different use cases. So high frequency trading, medical imaging and drug discovery, energy power consumption, supply chain and stock management, credit loan applications. And we also have we share an investor with the Starlight Group, who you may be familiar, those little kind of wheelie robots on the streets of Blackheath delivering your pizza. So we've worked in a number of different use cases, and these are examples of kind of how ML is changing the world. And forgive me if I talk about machine learning rather than AI. We consider ourselves a machine learning business, mainly because we see AI as quite a broad church. And actually what we're doing within machine learning is the deployment of machine learning models. I'm going to show you a paper that came out of Google some years ago at the NIPS conference, and essentially what the Scully team from Google did was they wanted to understand where were the technical burdens, the code blocks that exist within the machine learning pipeline. And so they came out with a paper and a graphic where each box corresponds in size to the lines of code required. And so this box is how much code your model demands, how much code it takes to train and build your model. And then these are all the things that go in and around that model. So data collection, extraction, loading and transformation, all of the process management, and then ultimately inference and serving. And those turquoise boxes are the areas that we focus. And so you can see now that actually when I'm looking at delivering a robust and a repeatable pipeline for machine learning model production, I need to be focusing an awful lot less on the model than I do some of the supporting infrastructure, because that's where my technical debt is going to sit. That's where my code burden exists. And these are the components that are going to become crucial for a robust architecture. According to Gartner, 87% of machine learning models never see the light of day. Now, that is significant because that's very often nothing to do with the model's performance and everything to do with the ability of the business to put that model into production. So if I cast your mind back to that Glassdoor statistic around data science salaries, if you're paying your data science teams not insignificant amounts of money to tune models that are never going to fulfill their potential, then you need to be asking the questions why. What is absent from my technical infrastructure that I need to have in place in order to ensure that I can see the value of these models? And so it's this area of ML ops that Selden plays. Our goal is to help business succeed with data science and bring together these very often siloed functions, these very siloed roles that are required to see success right the way through the machine learning pipeline. What is the problem, or rather, how do we articulate the problem at Selden? Well, essentially, it's one of the ML pipeline being broken. These are some examples, some archetypes who are essential within a ML workflow. Now, sadly, these functions are often siloed, not just ideologically, but often geographically. We work with a credit card provider and their data science team sits in a different country to the DevOps teams who are responsible for productionizing their machine learning models. That creates some issues because my DevOps function or app developer doesn't necessarily speak the language of data science. They are not in a position to be able to interrogate the algorithm with which they're productionizing. That is further compounded when there is no feedback loop to the data science team that authored the model in the first place. So data science throw the model over the wall, lands in a DevOps function who doesn't really know what they're productionizing, and they put it into production. And suddenly now we're in a position where, because there isn't a virtuous circle around model feedback and monitoring, you're potentially liable of putting something into production that you're unable to manage and monitor. And in fact, there's an example of this. On August 2012, Knight Capital Group which at the time was a leading financial market maker, experienced a major failure in the operation of its automated routing systems. It was taking small orders from retail customers and then mistakenly streamed thousands of orders per second into the New York Stock Exchange market over a 45-minute period. Thousands and thousands of orders hit the market, and Knight took an unwanted position of 3.5 billion stock. Well, Knight lost over 460 million from these unwanted positions, and by the next day, its own stock price had dropped by 75%, and the business was ultimately liquidated. This was all because the business had put models into production that it didn't have the appropriate governance and monitoring tools in place to manage. These are some of the challenges. These are some of obviously the downsides of productionizing models that you haven't managed. So how does this then relate to POCs? Well, from our perspective, it's very much about understanding not just about model performance, but also what are your monitoring tools? What is the management suite you have in place for production? And these absolutely need to be interrogated at POC stage, just as much as kind of model tuning. In fact, even more so, we would argue that you're better off deploying a toy model within the scope of your POC and then revisiting that model's performance, or indeed kind of retuning that, but having your deployment tools in place rather than focus solely on model accuracy and confidence. So these are some examples of delivery stages that we support. Right from trial through to kind of professional service provision to the production licenses of our enterprise suites. And we time box these, and for good reason, because I think Robin made the point, your projects shouldn't meander. There should be clarity about what your success criteria looks like, at what point they're going to finish, at what point you're going to conclude, and what a successful evaluation looks like. There are many things that should be considered within your evaluation stage. And Chris, I think, showed some good examples of that, and Robin had a breakdown as well in terms of considerations. These are some of the things that we're looking at as our default criteria for evaluation. Have we got everybody on side? Do we know what the cost looks like? And the cost not just in terms of kind of resource or technology, but also kind of the cost over time and when you're going to realize value. A lot of what we do is build versus buy analysis, because big organizations, and the bigger they get, the more likely they are to commit this sin. They think they can build it all. And very often there is an open source solution that is out there that doesn't require rebuilding. You know, stand on the shoulder of giants and use some of the more powerful open source technologies that are out there. You know, Chris referenced a great cracking example in terms of Intel's OpenVINO protocol, and that's something that we've obviously deployed through Selden. That's a fabulous example of why would you build that again? That's a fabulous solution. So these are some of the kind of the evaluation criteria, and this is by no means kind of complete, because you're going to have some essentials, but you can see here that what I haven't put in within the evaluation criteria is model accuracy, because that is something that we think can be revisited. More important to get your deployment pipeline robust and then go back and revisit model confidence and accuracy, because that is the easiest thing to do once you can demonstrate an end-to-end pipeline. So there's many things to consider there, but what are the essential attributes for a deployment? Well, first and foremost, it's about the problem. And I think the guys touched upon this in their presentations. If you're not addressing this challenge somewhere in the organization already, machine learning will not help. So we call this the intern problem at Selden. The idea of what is it at the moment that you're rubber banding? What is it at the moment that is causing a headache to you, and maybe you're throwing an intern or two at the problem, or there is someone in the organization is grappling with it. Is it a significant enough problem already that you're trying to tackle it? Now, it may well be that the way you're approaching it isn't successful at the moment, but you recognize that it is significant enough of a problem to address. To Robin's point, the Todd, what is the issue that is so pervasive, it's creating challenges for you, and you're putting someone on a constant basis to address. So the problem, can you articulate what it is you're trying to address? Do I want to reduce the amount of customers that are churning? Do I want to tackle my credit loan default? Do I just want to predict more cat pictures? What is the business, what is the challenge, and what is its impact on the organization? So that's the first essential. The second essential is obviously a data set. Do we have a machine readable data set that is available to us? Machine learning only works obviously when we can expose it to a machine readable input. And can we do that on a repeatable basis? It is not good enough that I can pull a one-off extract. If I want to make this a repeatable data science project, I need to be able to access that data all of the time. And finally, but by no means least, do you have domain experts that understand the data? So seldom very much we see ourselves as data science and deployment experts, but we are not experts in your domain. All too often, we see the domain experts of the organization divorced from the data science projects. And that's, again, a nonsense, because now you're asking the data scientist to address the problems that people on the ground in your business are facing on a day-to-day basis. Get their buy-in early. Get their understanding on not just kind of the profile of the data, but the profile of the problem. So what is it the customers want from a machine learning platform? Increasingly, it's about self-serve. They want to be able to have this access to deliver their own data science projects. They want to be able to collaborate across their DS and operations teams, and they want to be able to go from sandbox to production, not just at scale, but in a repeatable fashion. And what is it they're looking for? It's visibility and oversight of running models. So can I tell you why my model's doing what it's doing? Can I ensure that I'm logging everything that I need to, not just in terms of the model output, but also in terms of access? Who's touching the project, and what are the changes that are being made? What are my versions, and can I control those? And control and explainability, which I referenced earlier on. Can I show why the model's giving a certain output? And so we work within the context of MLOps. This is our discipline. We provide free trials, and why do we do that? Because we want to distinguish between free and POC. Very often there is an attitude that, well, this is a proof of concept, so why should I assign resource to it? Can't we do this kind of as a throwaway project? And in order to distinguish between POCs, we offer managed service free trials. This is essentially a road test of our platform. But what it does, apart from just giving people the opportunity to take a look at the horse's teeth in terms of Selden, it also provides us with an opportunity to distinguish from kind of the POC. And again, we time box the POC. So minimum 4 weeks, maximum 6. These need to be quick proof of concepts so that we can show how a toy model can potentially be deployed and the supporting architecture that you might need. And then we can move to proof of value. And again, those also need to be time boxed so that we can show progress and obviously further engagement from key stakeholders. These are some of the examples of support channels that we use within projects. So Slack, Asana, email, collaborative tools to work in an agile fashion. Even before COVID, well, obviously we were using video conferencing suites to provide support sessions every week to dive in on installation, architectural overview, have we got the right setup? Are we diagnosing and evaluating the right aspects and features? I'm going to share my slides, so I'll skip over a couple of these. Here, in particular, we have an example of a end customer where they were looking at specific KPIs with their POC and how we delivered against those, and then took that to enterprise level. And so, just want to summarize. What do customers want? They want time to value. They want to know that they can collaborate between teams. They want successful governance, and that needs to be repeatable. And when it comes to delivering a successful MLOps approach, the focus should be on supporting architecture before you're tuning your model performance. That can come Postgres. And then what are our essentials? Problem. Articulate the problem, define the data, and engage your people. That's me. Thank you.
Thank you so much, Lee. If it proves anything about this topic, is that we can do at least 2 more sessions on it. Just get to see how much people are sharing about it. So thank you so much, Lee, for your presentation. All that is left for me before I say goodbye to people who need to leave at 1 p.m., please stay if you can, is I just want to share with you the next session, the last one on the 24th of November, and that is developing AI at scale. So that's going to be our 6th and final session already of this series. Also, we've got other sessions coming up, if you could register for that. And also, if you could give us some feedback on this session and what we could do better, or what you really enjoyed about it, you can scan it on here. I'm sure that Abby already entered the link in the chat for that.